All right, now let's talk about the real world connection with arithmetic sequences. So let's talk about some real world connections with arithmetic sequences. All right, a dance studio charges $17 for the first ballet class a dancer takes and $11 for each class after that. What are the first four terms of an arithmetic sequence in which the total amount the dancer pays in dollars for taking and ballet classes? Okay, what are the first four terms? So they want you to come up with the first four terms. So they charge us $17 and $11 for the first class. So that means A sub 1 is 17, 11 after that. So add 11 to 17. 11, you would get 28, right? 1. Add 11 to 28, you would get 39. Add 11, so I'm going to keep adding 11, right? Adding 11. Add 11 to 39, and you should get 0, carry to 150, right? So the first four terms in arithmetic sequence, which is the total amount the dancer pays, would be 17, 28, 39, 50. What's the recursive form? All right, remember the recursive form is A sub n equals A sub n minus 1 plus D. And then you have to say what A sub 1 is, right? So based on this, we would say it's going to be A sub n equals A sub n minus 1. And then it's $11 after that, so that's our common difference. So we would say plus 11. And our A sub 1 is going to be 17. What's the explicit form? Explicit form is A sub n equals A sub 1 plus D parentheses n minus 1. So that means I'm going to say A sub n equals A sub 1, which is 17, plus D, which is 11, parentheses n minus 1. And that's it. That's that answer. All of this is the answer for the recursive. And these were the four terms. That's it. Real world connection. All right. Use the explicit form of an arithmetic sequence to find the nth term. All right. So they want you to write the arithmetic sequence. So again, A sub n equals A sub 1. In this case, it would be 6 plus D, which is our common difference in this case, which is 4. 4. And then parentheses n minus 1. A sub 20, so that means I would plug in 20 for n. So I'd say 6 plus 4, parentheses 20 minus 1. All right, so let me grab my calculator and put that in there. So I'm going to say 6 plus 4, parentheses 20 minus 1, close parentheses. Make sure I put that in there, right? First term plus common difference. The 20th term, so I plug in 20 for the 20th term. My final answer is 82. All right, and then for this next one, A sub 1 is 17. My common difference was -8, so that's going to be -8 here. Parentheses n minus 1. But now I'm going to plug in 16 for n. And plus -8 is just -8. 16 minus 1. So get my calculator again. So I'm going to say 17 minus 8 parentheses. That's not 8, sorry. 8 parentheses. And I can actually open up my keyboard and do this. 16 minus 1, close parentheses. Make sure I did that right. 17 minus 8 parentheses, 16 minus 1. And my answer is -103 for the 16th term. So whenever they say like A sub 16, that means they want you to substitute n is 16. Here, n was 20, and that's how we substituted in there. So just want to make sure you guys see that substitution. I plugged it in there for n. I was 16, so I plugged that in there for n. And that's how we use explicit form to find the nth term in an arithmetic sequence. All right. How about converting the recursive form of the arithmetic sequence to explicit form? So they give us the recursive form. Well, how do we get the explicit form? Well, they give us all the information we need to know. We know that a sub 1 is 39. We know that d is 21 because it says plus 21 here. So a sub n, remember, explicit form is a sub n equals a sub 1 plus d parentheses, that's plus d parentheses n minus 1. So a sub 1 we know is 39 because they gave it to us. The d is 21. And that's the explicit form of that recursive. Here's another one. All right, so we know a sub 1 is 42. D in this case is plus 8. Oh, that's supposed to say 21. So a sub n equals a sub 1. A sub 1 in this case is 42 plus, that's a sub 1 just in case you didn't know, plus d, which is 8, parentheses, n minus 1. And there you have it, the explicit form. Okay? What if you want to convert from explicit form of an arithmetic sequence to recursive form? Okay, so again, we know that a sub n equals a sub 1, this is explicit, plus d, parentheses, n minus 1. So based on this, we know that a sub 1 has to be negative 4. Based on this, a sub 1 has to be negative 4, and our d has to be 7. So then we would say a sub n equals a sub n minus 1 plus d, which is 7, and then a sub 1 is equal to negative 4. And again, the recursive form here, we can say that the first term, a sub 1, has to be 36. And our d has to be 16, based on where it's located in the form. So we would say a sub n equals a sub n minus 1 plus 16 for the recursive. And then we would have to say a sub 1 equals 36, because you have to say what the first term is in the recursive form. And this would be your answer. And by the way, this would be your answer. That's what say a sub n. So just think that that's a sub n. All right, well, what about a sub 16? How would you calculate that? Well, I would use the explicit form, 36 plus 16 times, and then I'm going to plug in 16 because it says a sub n. So 16 is your n now, and then minus 1. So that's how we use this recursive formula, minus 1. All right, plug that into your calculator. And so I'm going to say 36 plus 16 times 16 minus 1, close parentheses, 276. There you go. You definitely don't want to be using a recursive formula for that. That's a lot of numbers. 276 is your answer for a sub 16 in this problem, number 2. All right. And then finally, one more real-world connection. The table and graph below shows the number of points awarded to a player for finding a hidden door on a video game. The points earned for each level is an arithmetic sequence with a common difference of blank. So look at it. Let's see. 650 minus 500 is 150. 500 minus 350 is 150. 350 minus 200 is 150. 200 minus 50 is 150. All right, so common difference of 150. Write an explicit form of the sequence, then simplify. Well, the explicit form, remember, is a sub n equals a sub 1 plus d parentheses n minus 1. Well, level 1, I already know a sub 1 is going to be 50. Okay? So a sub 1 is 50. So I'm going to say a sub n equals 50 plus d, which in this case is 150, times n minus 1. Remember, we calculate the common difference up there. How many points will a player earn on a 24th level? So that means I'm going to say a sub 24 equals 50 plus 150 times, instead of saying n, I'm going to say 24 minus 1, because they told me what they want n to be. They want it to be the 24th level. Okay, so I'm substituting 24 here. And let me go ahead and rewrite this up here so you guys could see this properly. I'm just rewriting the same thing since I went into that fancy stuff over there on the end. All right, so this is when I get my calculator out. Work smarter, not harder. Get your best friend, Desmos. Okay, I don't need it to be that big. I'm going to refresh that. And I'm going to plug in there 50. Ooh. See if I can minimize this some more. There we go. All right, I'm going to say 50 plus 150, open parentheses, 24 minus 1, close parentheses. Make sure I put that in there correctly, right? And 3,500. So a sub 24 is equal to 3,500. And that's my answer. An arithmetic sequence is a linear function whose domain or x values is a set of natural numbers. This is very important to know. All right, so an arithmetic sequence is a linear function whose domain is a set of natural numbers and whose range or y values is a set of terms of the sequence. Recall that a linear function has the equation y equals mx plus b, where m is the slope and b is the y-intercept. In an arithmetic sequence, the common difference is equal to the slope of the line. So the biggest difference between an arithmetic sequence and a linear function is that the domain of an arithmetic sequence is a set of natural numbers. Okay, like your whole numbers, 1, 2, 3. It starts at 1. 1, 2, 3, 4, 5, 6, the set of natural numbers. We use a capital N to represent natural numbers. All right, and that is it for our lesson today. You guys have a great day, and ask your teacher if you have questions. You can rewatch this recording, okay?